Scenario. Satellite A is in a circular orbit around an unknown planet with an orbital speed of VA. Question. What are the variables that can affect the orbital speed of satellite A? Here's the answer. The equation is derived from setting Fc equals to Fg, which is the centripetal force is equal to the force of gravity. Once you derive it, you should come up to the conclusion of velocity A is equal to the square root of big G, which is the gravitational constant, times the mass of the planet divided by R. The mass of the planet is going to affect it, which is on top of the fraction, so that is a direct relationship. And the distance between the satellite and the planet is R, which is on the bottom, so that has an inverse relationship. The note that G is the gravitational constant, it is not a variable, so it does not affect the orbital speed. So the only two things that affects the orbital speed is the big planet that the satellite is revolving around and the distance between that satellite and the planet. Here's a follow-up scenario. A comet now collides with that satellite and knocks it further away from the planet. The new distance away is 4 times as before. What is the new orbital speed of the satellite? Here's the answer. The new velocity, I'm going to call that v1, is equal to the square root big G times mass of the planet divided by 4r. The 4r represents the distance away is 4 times as before. Now I'm going to pull out the 4 which is on bottom, so it just is 1 over 4 times everything else. Notice that I can now split this using my properties of exponents and radicals. Notice that the right hand side here, the square root of g m planet over r is as before, which was equal to VA. So that is VA. VA was the original orbital speed. So once you introduce the 4 times as much, you should see that it becomes 1/2 of VA. So the new orbital speed of the satellite will be reduced by a factor of 1/2 because it is now 1/2 due to it being 4 times away as before. It A lot of students get this wrong because they think it is going to be weak by like 4 times as much. No, it doesn't. Or sometimes they think it's weaker by 16. No, it's not. If you work through the deviation here, it's only divided by a single r. So it's only the square root of r that affects it. All right? So there you go.